Alright, so this is the first video on interior and exterior angles. And this video is going to only address the interior angles. And so the difference between an interior and exterior angle is interior angles are on the inside of the polygons, and as where exterior angles are on the outside of polygons. So all these angles, this right here would be an interior angle because that's on the inside. And let's see if I can draw an exterior angle here. If this goes out, imagine that going out like that. This angle, I'm going to use a different color. This angle right here is an exterior angle because it's on the outside. Okay. So just like if you were to paint the inside of your house, you would use interior paint, and if you were to paint the outside of your house, you would use exterior paint. Okay. And so what we're going to first work on is how to find the total sum of the interior angles. Okay, so the total sum. So if we were to add up all the angles inside one of these polygons, how many degrees would it be? And so you might already know for a triangle it's 180, and then you might also even know for a quadrilateral, a shape with four sides, that it's 360. But we're going to use a formula because on the test, if they ask one of these questions, it's usually not a triangle or a square. It's something with more sides than 3 or 4. So as I just mentioned, there is a formula, and just like all the formulas, they're on the Ames reference sheet, and so you want to make sure you know where those are on the Ames reference sheet. So let's take a look at the Ames reference sheet right now and see here. So zoom out so we can see the whole thing. So this is your Ames reference sheet, right? This is the first page, and the back page here with the circles. And on the side with the circles where you're going to find this. So if you look at the very top here, it says the sum, and let me zoom in so that you can see a little bit better. Okay. It says the sum of the measure of the interior angles of a convex polygon with n sides is this. And so it says convex, but it's actually it could be a concave as well. And if you don't know what convex and concave is, I'll show you here in a second. But what we're going to do is we're going to copy this formula down so we have it for the problems we're going to try. So here we go. Let's get rid of this now. Okay. So this right here is our formula, and it's a pretty simple formula. You only need to know there's only one variable, n, and if you remember from your geometry days, the n here, in n minus 2 times 180, the n stands for the number of sides. So you take the number of sides, subtract 2, and then times it by 180. And so let's try one of these. So we said before that the triangle should have 180 degrees inside it. Its interior angle should sum up or add up to 180 degrees. And so let's try this. So triangle has 3 sides, so we're going to do right over here 3 minus 2 times 180. See if I can do that. And so 3 minus 2 is 1, and 1 times 180 is 180, so that works. Okay, 180 degrees. So the next one here, I said earlier it should be 360, but again, let's try it. This is a quadrilateral. It's got 4 sides. So we're going to do 4 minus 2 times 180. And so 4 minus 2 is 2, and 2 times 180 is 360. Okay, and so that's what we wanted. Okay, and so a lot of people memorize that and say, well, why do I need this formula if I know the triangle is 180 and a quadrilateral is 360? Well, that's good that you memorize that, but they're probably going to ask you a question with more than 4 sides. So let's just take a look at a polygon with more sides here. This is a pentagon. It's got 5 sides. So again, you just use the formula. It's 5 minus 2 times 180. Okay? 5 minus 2 is 3 times 180. Okay? And you could do that, but in my head I can do that. That's going to be 540, and there's your answer. Okay. So the Ames reference sheet says convex polygons, and so all of these up here are convex polygons. The other type of polygon is called a concave polygon. You might remember this, but basically a concave polygon is a polygon that goes inward. So if you look down here, this is the concave polygon because this goes inward like that. Where none of these go inward like that, if you know what I mean like that. But regardless, this says for convex, but it's actually for either case. So this right down here is a concave polygon. So same thing, you're going to just count the number of sides and then subtract it from 2 and times it by 180. So if we go 1, 2, 3, 4, 5, 6, we got 6 sides this time, so we're going to do 6 minus 2 times 180. And so 6 minus 2 is 4, and 4 times 180, I believe, is 720. So we got 720 degrees. Okay, and so it does say convex on your Ames reference sheet, but it could be a concave. I don't know why they say that. It could be either or. Okay, so let's take a look at maybe another type of problem, how they could ask us. So that's for the total sum. We're going to add up all the angles. So let's look at another question here. And so here's a question. It says, find the measure of angle A. So it tells us all the other interior angles, but it doesn't tell us the measure of angle A. We need to know this angle right here. And so the way we're going to do this is we're going to add up all of these angles, the ones we know, and then we'll figure out the total sum of those, and then we'll figure out how many total degrees of the interior angles there should be, and then we'll subtract the two. So again, what we're going to do is we're going to use our formula, n minus 2 times 180, to figure out the total sum of all the interior angles, if we had all of them, what they all should add up to. And then we'll take the angles that we do have and add those up and subtract the two, and what's left over should give us this angle A. Okay, so let me do an example of this right here. So the first thing we're going to do is figure out the total sum. So we're going to need another one side. So 1, 2, 3, 4, 5, 6. Okay, so that's 6 sides. So if you remember, we would do 6 minus 2. Oops. Let's start over there. Okay. A little bit harder than that with a marker. So here we go. Try that one more time here. 6 minus 2, put my parentheses, times 180. And so remember from before, 6 minus 2 is 4, and then 4 times 180 was 720. So we're just going to write 720 degrees. And that's the total number of degrees. If we added all of them up, that's what it would be. And so now what we've got to do is figure out how much, if we add all these up, what they'll add up to. So I'm going to do that over here on the side. Okay, so we got 120, we got 128, we got 138, we got 90, and we got 160. Okay, and we're going to add all those up. So we got 0, we got 16 there, 8 plus 8 is 16. We go put our remainder up here. So we got 1 plus 2 is 3, plus 2 is 5, plus 3 is 8, plus 9 is 17, plus 6 is 23. So we got 3 here, and we bring a 2 way up here. We got 2 plus 1 is 3, plus another 1 is 4, another 1 is 5, another 1 is 6. We get 636 degrees. And so whatever's left over from subtracting this 636 from 720 will be angle A. So let's try it. We subtract the 2 here. We're going to make that a 1 and 1, so 10 is a 4. We get rid of that. We get a 6, 11. That makes that 84. Okay, and so that tells me that angle A, or the measure of angle A, is equal to 84 degrees. And if you look at the picture, and these aren't always drawn on the scale, but it usually helps to look. If you look at angle A, it looks like it's less than 90, because we kind of know what a 90-degree angle is, like angle C is a 90-degree angle. And this is less than 90, and it makes sense that our answer is less than 90. So that's sometimes a good way to check to see if you are close to the right answer. Okay, so let's look at one more that's somewhat similar, and then we'll be done with video 1 here. So it says, find the measure of just one of the interior angles. And so that's kind of a little bit different. And so what you would see here is that these are all congruent angles. All the angles are the same. So it doesn't matter which one we find, because they're all going to be the same. So the way you solve this problem is you figure out the total sum of all the interior angles, and then you divide by the total number of angles. So you first figure out how many total there are, using your formula, n minus 2 times 180, and then you would divide by the total number of angles, and and what that is would give you each one of these angles. So you would divide it up evenly. Okay. So let's see, we got 1, 2, 3, 4, 5, 6. We got a hexagon. And so if you remember from before, our formula for a 6-sided shape, it's 720 degrees. Okay. And so we need to divide that 720 degrees up into 6 equal angles. And so to do that, I'm just going to divide it by 6. And so 6 goes into 72. Let's see here. What, 12 times? Okay. I believe that's right. So 6 goes in there evenly. So 0, 0, 6 goes into 0, 0 times. So it would be 120 degrees. Divide that in there. So what that means is each one of these angles is 120 degrees. Okay. So that's the first video on just interior angles. The next video will discuss exterior angles.